Today I'm going to show you how to implement open source models in Microsoft AutoGen using Groq's high-speed inference service. This includes the powerful multimodal model LLaVA 1.57b, which became available on Groq just a few days ago. This is a big deal for AI applications that need to process both images and text, and do so quickly. First, let's talk about Groq. They provide a high-speed inference service that runs on their language processing unit, or LPU. This hardware is specifically designed for AI inference and language processing, allowing for incredibly fast processing speeds when running open source models like LLaVA. This diagram highlights the key differences between GPUs and LPUs that make LPUs faster for large language model processing. GPUs have non-deterministic execution, leading to unpredictable performance, complex hardware resulting in resource contention, and hardware-managed data flow that can produce bottlenecks. LPUs, on the other hand, feature deterministic execution, ensuring predictable performance, simplified hardware, allowing for efficient resource use, and software-controlled data flow, which optimizes data movement. These characteristics make LPUs faster for large language model processing compared to GPUs. Now let's talk about LLaVA, the large language and vision assistant. LLaVA is a powerful multimodal model that combines language and vision capabilities. It's based on OpenAI's CLIP and a fine-tuned version of Meta's Llama 2 7B model. It supports visual question answering, caption generation, optical character recognition, and multimodal dialogue. Here's an impressive fact. In September 2023, LLaVA 1.5 achieved state-of-the-art performance on 7 benchmarks. This shows just how strong it is at understanding and generating text based on visual inputs. To show you how powerful this combination can be, I've developed a Python application. I call it Web Vision Pro, and it's designed to create a detailed analysis of any web page you provide. Before we dive into the demo, I want to point out how easy it is to use Groq with AutoGen. If you're interested in the technical details, check out the AutoGen Groq documentation. I'll leave a link in the description below. Now let's see Web Vision Pro in action. Input the URL of the website you want to evaluate. We'll use NVIDIA's URL for this demonstration. Select the depth analysis. This tells agents how detailed their individual analysis should be. What happens behind the scenes is pretty cool. The app creates a screenshot, scrapes all the content from the website, and generates a detailed description for a group of AutoGen agents to analyze and provide feedback on. Then click Go. And there we have it. Notice how fast the results came back. That's the power of Groq's high-speed inference service. This would have taken much longer if we were running it locally or even had it running on powerful GPU services. And this is a highly detailed report with a lot higher quality than what you would get if you were just doing one query into an LLM. We have a usability report, accessibility evaluation, performance analysis, and the summary report, as well as a design analysis. And we also have a little screenshot of the site that we analyzed. Okay, so now let's take a look at the code behind this project. In the website_analyzer.py, we're generating a detailed description to provide to our agents. We're using libraries like Beautiful Soup for web scraping, Playwright for capturing screenshots, and Pill for image processing, and the Groq library for interacting with the Groq API. The main function, Analyze Website, takes a URL as input. It handles the entire process of fetching and analyzing and processing the website data. We ensure the URL has the proper schema. We fetch the website content and extract the text using Beautiful Soup. We generate unique file names for our screenshots and thumbnails using timestamps. This ensures we don't overwrite previous analysis. We use Playwright to capture the screenshot of the website. We set the viewport size to 1920 by 1080 to ensure consistency across different analysis. The image is then encoded to base64 format, which is required for sending it to the Groq API. We set up the Groq client using an API key stored in our environment variables, and specify the LLaVA model we want to use. We prepare a prompt for the LLaVA model, asking it to analyze both the visual elements from the screenshot and the textual content we extracted earlier. The request is then sent to the Groq API. We're using their chat completions endpoint, sending both the text prompt and the encoded image. Then we extract the analysis from the API response. In agents.py, we're setting up our AI agents using the AutoGen framework. This is where we define how the agents will interact and what tasks they'll perform. We first import the necessary libraries. AutoGen is the framework we're using, and OS is to access the environment variables, such as the AutoGen key. And this is the Groq API configuration. This list contains the configuration for connecting to Groq's API. We're using the Llama 370B 8192 model, but this can be changed to other Groq models as needed, or we could be using a local model for this if we were using Llama. And we can get into how to do that in another video. Then in this first function here, we create the agents with a depth-aware instruction. This function allows us to create agents that can adjust their analysis depth based on user requirements. And we have parameters such as the name of the agent, which is used for identification in the group chat, and a system message. This message includes the base instruction and a note about adjusting the depth. And the LLM config instructs which model to use, which we're using the Llama 370B. And next we define specialized agents for different aspects of web analysis. Each agent is created with a specific focus area and the ability to adjust analysis depth. First, we have the design analysis agent. This agent focuses on visual aspects of the website. Next, we have usability expert. This agent evaluates the user experience and ease of use. Accessibility evaluator. This agent accesses how well the website can be used by people with various disabilities. And we have the performance analyst. This agent looks at the technical performance of the website. Then we create a summarization agent to compile insights from the other agents. This agent doesn't have a specific analysis focus, but instead synthesizes the findings of other agents. Here we create a user proxy agent to manage the conversation flow. This agent acts as an intermediary between the user and other AI agents. This line defines when to terminate the conversation, and this agent doesn't require any human input during the conversation. This prevents the agent from replying to itself. And here we collect all the agents into a list for easier management. We set up the group chat with all agents and a manager to coordinate the conversation. The group chat allows all agents to communicate with each other. The max round limits the number of conversation rounds to prevent infinite loops. And here we customize the analysis depth based on user input. This allows for flexible depth of analysis without needing to recreate the agents. And this is our main function to analyze a website. This orchestrates the entire process, including error handling. We get the appropriate depth instruction based on user input. We initiate the conversation with the user proxy. And finally, we extract the results from the group chat. And we have this function to extract messages from specific agents in the group chat. This organizes the analysis results into a structured format. We match each message to its corresponding agent and store the content. And this is used to extract all messages from the group chat. This is useful for debugging or providing partial results in case of an error. The combination of models like LLaVA and Groq's high-speed inference service and multi-agent frameworks like AutoGen is opening up exciting new possibilities in AI applications. These are tools we can experiment with to push the boundaries of what's possible. I'm really interested in hearing your thoughts. Have you experimented with multi-agent frameworks or multimodal models like LLaVA? What applications do you see for this technology? If you want to try this out for yourself, I've put together a GitHub repository for WebVision Pro in the description below. It contains all the instructions you need to get it set up and experiment with the tool. Before you go, let me know in the comments what you'd like to see next. Are you interested in more agent frameworks, or maybe topics like RAG, AI privacy, or implementations in other languages like C#? Your feedback shapes future content. Thanks for watching, and until next time, keep pushing the boundaries of AI.